Hi everybody, this is our project ReiniSpec, which is an improved speculum for gynecological exams. Unfortunately, one of our team members, Caroline, is in quarantine with COVID, so we will be presenting without her today. Oh, okay, there we go. So what is a speculum in the first place? A speculum is a device used to view the inside of the vagina and the cervix. According to General Electric, its current design has gone essentially unchanged, as you can see, for the past 150 years. It was originally designed by men and has historically been operated by men, even though it is primarily used on women and people with vaginas. So we've spoken to gynecologists from local hospitals, and we've concluded that there is a real need for an improved speculum. Doctors have cited issues such as pinching of the skin and the pubic hairs, inadequate sizing options, and a lack of modularity. Our own project's clinical mentor has told us that no woman is happy with the current speculum. So with nearly 60 million pelvic exams being performed each year, there is a huge market for products in the realm of gynecological exams. The first issue associated with its current design is its inability to serve obese patients. With obese patients, there is excess tissue in the vaginal canal, which can then block the view of the cervix, and the current speculum design is unable to support that excess tissue. With nearly 40% of women in the US being obese, this affects a huge proportion of patients. There's also a risk of cross-contamination. So in one study comparing women with urinary tract infections to a control group, significantly more women with UTIs had recently received a pelvic exam with a speculum being used on them. This specific study estimates that up to 6.9% of UTIs result from an exam with a speculum, which indicates a real need for a device that is easily and effectively sterilized. The misdiagnosis of vaginal afflictions is also extremely common in gyno. The most common and life-threatening misdiagnosis is cervical cancer with a 40% rate of false negatives, so it often goes unseen and undetected. Whoops. There's also a 40% rate of misdiagnosis of ectopic pregnancies and a 37% rate of misdiagnosis for sexually transmitted infections, with the rate being even higher in children. And then lastly, the physical and emotional discomfort experienced during the gynecological exam is highly documented. So in one study, 30% of women, middle-aged women, reported somewhere between mild and moderate discomfort. But within that same study and age group, an additional 36% of women reported strong discomfort. So that's why with ReiniSpec, we aim to improve the experience of the patients.
So there are several issues associated with current speculums. Plastic speculums are extremely wasteful as they are all single-use products. Hospitals endure high costs because they must purchase thousands of these products every year to be used just once. In addition, a gynecologist sees several different size patients in just one day and often must try several sizes of these plastic speculums on one patient to find the optimal size. Metal speculums have very cold and hard surfaces that can result in pain and discomfort for patients. These products are also made up of screws that can pinch the vaginal tissue when the doctor makes an adjustment during an exam. So our team of female bioengineers and entrepreneurs have addressed this need for a redesigned speculum, and we're excited to present ReiniSpec to you. So ReiniSpec began in October as initially a computer designed model. Then in December, we were able to 3D print our first physical prototype that included a camera, cheap LEDs, bulky servo motors, and low-quality silicone material for inflation. But after surveying doctors as well as patients, we've elected to remove this inflatable feature as it has not been shown effective to improve patient comfort or diagnostic outcomes. However, in our final model, we do have this silicone material sheath across our device because this has been proven to increase comfort by just the material itself. So now we'll take a closer look into all of the features that encompass our final, newest and fully integrated prototype, including mechanically adjustable arms, as well as a camera aided by machine learning for better diagnosis.
So first, we can adjust the angular opening of the speculum. Now, as you can see here, it's done the same way that it's done with current disposable speculums, so doctors don't have to relearn this piece, and it can be opened to about 30 degrees. However, we can also adjust the arm length electronically. Now, this is a novel addition and basically allows for the accommodation of patients with different dimensions without having to reinsert or take out the speculum and try again during an exam. Our system consists of a servo motor connected to a spring, where when the servo spins, it compresses the spring, storing energy and shortening the arm length. Then when the servo spins in the opposite direction, it releases the spring, increasing the length of the arm. Using our system, we can adjust the servos, the speculum's arms for about 7 to 13 centimeters to accommodate a variety of patients. In order to improve patient comfort by providing a better surface that can give when you're applying pressure to it, we decided to include the silicone sheath. Now, we chose silicone because it's been proven to be both biocompatible and autoclavable, while it also removes that cold, hard sensation of cold metal upon the skin. Also, because the silicone provides this extra give when pressed against the body, it decreases the pressure, increasing patient comfort when compared to a hard plastic or metal. In order to validate this, we placed pressure sensors inside of a vaginal model and performed an exam using a plastic speculum, a metal speculum, and our improved design. Now, we can use pressure as an analog for pain, so if our design decreases the pressure exerted on the model, it's decreasing pain. We found that there was a 3.8% decrease when compared to the metal and a 6.6% pressure decrease when compared to the plastic. We did perform an ANOVA, which showed that this was a significant change, and after talking to gynecologists, we believe that this will be a beneficial feature.
Okay, so another issue that is commonly faced by gynecologists during the exam process is inadequate lighting. So without adequate lighting, gynecologists might take longer to actually analyze the cervix, which in turn prolongs the discomfort that a patient might feel during the exam. Also, using an external lighting device can prove unwieldy, as the doctor would have to juggle like 2 devices in one of each hand. So that's why gynecologists and nurses have specifically requested an LED that is directly integrated into the device. With ReiniSpec, we've done just that. We've integrated an LED into the handle of our device. We've also integrated a modular camera feature that can be used to take pictures. So with this video, we'll show you our GUI that we coded using a Raspberry Pi computer, which interfaces directly with the LED in the camera. So on my right, so your left, is our GUI interface, which is used to control the electrical components of our device. And then on the left is the accompanying camera recording that we took inside of our vaginal model. So as you can see, besides having an LED button, there is also adjustable camera brightness, exposure, and ISO, otherwise known as light sensitivity, that can be changed in real time to take higher quality images. So as we mentioned before, cervical cancer is an affliction that has often gone missed undiagnosed without any additional help. So by being able to take pictures, doctors can save and compare images from multiple exams to track the progression of a disease state. And besides being able to control and interface with the LED in the camera, this GUI is also used to control the mechanical extension and contraction of our device's arms. This way, doctors can actually make real-time size adjustments while the device is still inserted into the patient, removing the need to repeatedly insert and take out multiple different size devices, speculums, in order to find the right size. So in an effort to extend the capabilities of our camera feature, we've incorporated a machine learning model to differentiate between different disease states. We started by collecting approximately 500 images using our professional vaginal model. And then we converted those images into usable data by simply concatenating and then flattening its RGB values into a 1D array, where each element in that array serves as an individual feature of the original image. From there, we split the data into an 80-20 ratio of training to testing data, and then we put it into 3 different types of models for feature classification using Python's sklearn library, a very common library. We performed a cross-validation step to help us identify which model is the most capable of predicting never-before-seen data, and the same model that was the best at doing that also had the highest testing score, so that was our support vector machine, which was chosen as our best model. So at a 93% accuracy score, our model can differentiate between healthy patients and those with a common infection, those with inflammation, and those with early-stage cervical cancer. With models like these, they can kind of serve as a warning for doctors to re-examine a patient if the model detects something that the doctor didn't initially detect during the exam process.
In order to validate ReiniSpec with our stakeholders, we also surveyed several pen gynecologists and received a number of positive results. 92.8% of gynecologists found that the adjustable mechanical arms would be very beneficial. 100% of them found that the LED with adjustable brightness would also be very useful, and 100% of them would be willing to use our machine learning model at its current accuracy. Patients are another important stakeholder, and so we sent out our survey to many people in our patient population. As you can see, 85% of them would prefer ReiniSpec to the traditional Speculum. 92.3% of them think ReiniSpec would increase their comfort, and 92.9% of them believe that they would feel more at ease at a gynecological exam if ReiniSpec was used instead of the traditional Speculum. So as we move forward with our venture, we plan to make sure that our silicone sheath is more easily removable, this in case of damage and for ease of cleaning. We also intend to apply for a provisional patent, and as we are doing so, we plan to apply to more competitions and grants related to women's health. Finally, once we receive IRB approval, we plan to validate ReiniSpec with actual patients. We'd like to thank our sponsors and mentors, as well as the BE Lab, for providing us with advice and assistance through this process. Designing for patients and women, ReiniSpec helps improve patient comfort and diagnostic outcomes. Thank you so much for listening to our presentation. We're happy to take any questions.
So great presentation, and it was very clear what you guys were going for. The question that I have, so you're doing a lot. I was surprised at the end when you started talking about using machine learning algorithms in order to do diagnosis. Can you speak to me a little more about what features are you extracting from these images or videos in order to do a diagnosis? And sort of, are you landing on a binary determination of yes, no? Are you giving a score? Yeah.
Yes, oh, definitely. So the first question was, the features that we're using. Yeah, so we ended up trying a bunch of different types of features. We tried using the average of all the RGB values, the sum, the energy calculation, the line length, all of these things, but none of them gave as good of an accuracy, and we did check for overfitting. None of them gave as good of an accuracy as just simply using each individual RGB value as an individual feature. So there ended up being 150 times 150 times 3 elements in an array where each one serves as an individual feature. And then for the second part of the question was...
Do you get a score, or is it just telling you yes or no?
It is not a binary classification, actually. So we'll show you later during the demo that there's actually a percent breakdown for... There were 4 different disease states. There were 3 diseases and 1 normal state. And then it gives a percent breakdown for each type of image, the guess for how similar it is to this category versus the other category. So it's not binary. Mm-hmm.
And do you do corrections for you have exposure, you have all sorts of variables within any kind of imaging system, right?
Yes, definitely. We'll show you different photos where some of them are darker, some of them are more zoomed out. Do you want to speak to that? Yeah.
Also, we took a variety of photos. This is very close to me. In the future, one thing we'd really like to do once we can get IRB approval and all is get a sample group, because the pictures are used with the vaginal model currently, because it takes a lot of approval to get pictures, especially of this sort of area with this topic. And so for the next stage to improve the machine learning algorithm, we plan to get photos from actual patients, yeah.
I was wondering, in your design, so common with getting a gynecological exam is that the doctor will take a cell scraping. Is it still possible to do that with your Speculum device?
Absolutely. Caitlin can speak more about the actual mechanical shape of the device, but it is very similar to the original design, and still in that you still have the aperture opening and you still have a hollow opening in order to reach in your scraper to actually get a sample of cells. There's also the camera.
Yeah, I mean, the only thing that's obstructs the view a little bit is the camera, which is made up for by the fact there's a live feed, but there still is space above the camera to go in and do a scraping.
I'll ask one. I was just curious why do you think cameras and imaging haven't already been incorporated into this, or like if you know of any alternatives that are looking into that, just trying to understand like why this hasn't been done yet.
It actually has been. There are some plastic speculum that do have cameras and do have lights. However, they are significantly more expensive. I believe the one that we found on the market was $1,000. So it was $1,000, and ours is significantly cheaper, and it's also reusable, so you can just buy one of them and be able to get images of several different patients with the same one. There's also the fact that because we're putting a camera and touch in an area that is very sensitive, just socially, there is a lot more trouble with getting pictures, getting kind of approval. So it's just a more difficult area to work with, which is why there's a limit in the innovation in this area.